Okay, so panelists, come on stage, and I'll just start by giving you folks a little background. But before we go into the background, put my paper down, I just want us to take a reality check. All the people here that planted the seed, developed that seed of Ethernet, do you realize what great jobs you've created for people all over the world? Really? It's fantastic, fantastic what you folks have developed. Anyhow, I'm going to take about 2 or 3 minutes, and I'm going to give you a little background about Ethernet and carrier networks. I got to do this. Did that do it? No. There we go. Let's do one more. Okay, just to give you a frame of reference or a little perspective on Ethernet and carrier networks, Ethernet became popular in local area networks. Years ago, you had structured cabling. Before structured cabling, it was unstructured cabling. Do any of you guys remember that thick black coax cable above the ceiling rafters? There you are, good, good, thanks. I just remember the one coming down. Anyhow, and do any of you remember when token ring was bigger than Ethernet? Yeah, so we had some proprietary structured Ethernet. What this shows is shared Ethernet and token ring. We had FDDI, ATM. Does anybody remember DAISY systems? All right, and Proteon? Great. Cabletron? Yeah, yeah. Anyhow, Ethernet in enterprises was quite popular in the 90s, and then sometime around this early 90s time frame, we came to switched 10 meg Ethernet, and switched 10 meg Ethernet only lasted a couple quarters, and then bam, it went over to 100 meg Ethernet, and it's Howard's company and a couple others that just turned the whole market on its ear. Look at the scale there. It was rapidly up to like a $10 billion market. Right now, this is just Ethernet switches. All right, there's Ethernet adapters, you've got Ethernet and optical transport, you got a lot of other Ethernet. But this is the mother of Ethernet here in the LAN. And we're at about $20 billion a year. Just to show you the longevity. Now, who do I point this at? Oops. Now, just to turn to the panel here, set you guys up, Ethernet started out in carrier networks back in the early 2000 time frame using the LAN type of equipment in the carrier networks. But then we got these carrier-style Ethernet switches and routers, and as you can see, they started replacing those frame relay ATM switches. And this is a relatively new market, and it's growing quite rapidly. New applications like LTE will probably drive it even farther. So now we're going to switch over to the panelists here, and we are going to ask them to each talk about how Ethernet is important to their business or how it's been important. And perhaps, Howard, we'll start with you. Howard co-founded 3Com and then started Grand Junction Networks, which innovated 100 gig switching or 100 meg switching. We've got Saeed over here at Juniper Networks, came from Redback, then went to Ericsson, now over at Juniper on product and technology. We've got Mark over here, who went to start Hatteras Networks and is now over at Overture. And we've got James here at TATA Communications, who is spearheading the Ethernet business at TATA. And we've got Yali over at Verizon, who is in product and technology on Ethernet and internetworking. So please, Howard.
Thank you, Tam. So you have to understand that Ethernet, and I know you do understand this, comes from the LAN world. And it really wasn't a carrier technology. And in fact, we fought viciously wars specifically about the physical layer. And I do understand why we did that, but now it all seems for naught. Because you remember what John Schock said earlier this morning. He said that, we don't really have carrier access anymore. We don't really have multiple stations accessing the cable at the same time. And we don't really have collisions anymore. So what do we really have? And it's an excellent observation. Because now, despite the fact that we fought those physical wars, we now only have what remains, which is the frame. The frame remains what's really valuable. And even though we did fight those wars in the standards bodies, the frame is the heart of gold. And it is the frame which allows us actually to move forward and make speed irrelevant, because if we really were attached to the physical layer, we couldn't be going to 100 gig and 400 gig and maybe a terabyte. It just wouldn't work. So what's going on right now is we are making this carrier, if you will, suitable by keeping the frame and by moving to different physical interfaces that serve our needs. I used to use this rule of thumb, which was every time we change the protocol, you're going to take a 50% performance hit. Every time. And so there's this beauty in not changing the frame. Now, whether that rule of thumb is right or not is not what's important. What is important is that carriers are in the business of selling services and making money. And if the efficiency goes down of the network, this is a bad scene. It can't work. So, by retaining the frame format, this is what's gold. And so what's happened over the years is the practice has evolved. And how has it evolved? Well, we would send Ethernet over SDH and SONET, or we would send Ethernet over IP, MPLS. And now, what the Metro Ethernet Forum stands for is we go to market with carrier-based Ethernet. We don't have to send it over something else. It's a service. And so this whole thing has evolved now, so we don't have to change the frame. And that's really, really a good thing. And so when you ask the question, is this important to us? It's really important to us because it has become the go-to-market. So I asked our people, is this a criteria, a buying criteria? It turns out, no, it isn't. And you might say, well, how could it not be if it's that important to you? It's so important, it's not a criterion. It's to get in the door. It's table stakes. If you don't have this capability, if you don't have this ability to provide these services, you just don't get to play. So it has become so integral to our business that it is synonymous with our carrier provisioning and sales.
Saeed or Mark, you want to take up?
Sure, I can go ahead. I think coming also back to the question that Bob asked earlier, what does it mean to Juniper? I think Ethernet for us is an enabler. It's an enabler for our business. If you look at our switching and routing business, the majority of the ports we ship today are Ethernet ports. Now, on the switching side, you probably are not too surprised because, switches, we've had the LAN wars in the 90s, and Ethernet came along and won. But I think if you look at the routing business, when we as a company built basically the first purpose-built router for the internet, we didn't necessarily think about Ethernet as the primary means of connectivity. We built it for any interface. Ethernet was just an interface that we put on our routers, like we put SONET, SDH, etc. Now, if you look at what happened in the early decade, last decade in 2000, 2003, I remember being with customers, and every customer was asking us, talk to us about Ethernet. Talk to us about what you're going to do with Ethernet. And in the beginning, you go like, okay, well, why are everybody's talking about Ethernet? And in the old days, we used to talk about Ethernet as just an interface, and now the importance of Ethernet went up. And we were like, why? Well, we think Ethernet can help us to keep up with bandwidth growth. We think it can make it cost effective for us. We think there's now an industry, an ecosystem that has scale, and that scale we think we can reuse in the service provider business. So we went off, and actually, for us, the answer was to actually build the first Ethernet router, right? A router completely engineered for Ethernet. And it meant it was Ethernet in the design process, not at the end, we're like, okay, the router is done, what are we going to put around it? No, Ethernet was in the first step of the design process. And we talked about, we had to talk about the physical footprint, the Ethernet density, the price per port that we wanted to meet, and how we're going to be able to scale that up over time from a gig to 10 gig to 100 gig today as a kind of our density leading design criteria. So Ethernet is very important for our business, and we're very glad for all the work that has been done by a lot of people here in the last 40 years, and thank you for that.
Great, thanks, Saeed. Mark?
Really, I'd like to start where Saeed left off and talk about, as you asked, what does Ethernet mean to our business? Well, my company, Overture Networks, is in the business of providing carrier Ethernet hardware, software, and services for service providers at the metro edge. And what does that mean? That's really that last mile of connectivity to businesses and to mobile towers and to data centers. And so what's been fascinating for us and what's really important, well, let me just back up. The reason Ethernet's important to us is because it's important to our customers. And what Saeed said rings true with our customers, in that the service providers had come to us and said, we believe in Ethernet because we believe it's a way to deliver higher bandwidth at a lower cost per bit, and we can build it on a reliable ecosystem that's evolved. And what's been fascinating to watch is how Ethernet has evolved in the carrier space over these years. I mean, I remember the mid-90s when there was this thing called transparent LAN service, and hopefully some of you guys remember that. But it was really run out of a couple of cowboy-operated service providers that really thought they could get a jump on some of the incumbents by delivering really high-speed connectivity in sort of fiber-rich areas in metropolitan cities. And that evolved, from small kind of competitive operators into the major operators. I remember Bell South had a service they called Nimly, and it was an Ethernet-based service where they deployed an enterprise switch in the central office, and they put little media converters out at the edge of the network. Well, this has really taken off, obviously, and evolved, to the point where there's, millions of connections around the world in Ethernet as a service. And it's amazing because it started off as dedicated point-to-point connections, often Ethernet over SONET, but it also simultaneously became a sort of dedicated Ethernet connection out to a building. But then as branch offices needed to come online with a corporate, overriding switched Ethernet service, then technologies like Ethernet over voice-grade copper came on board, and so we have Ethernet over bonded copper now, Ethernet over T1s and E1s, and Ethernet over the air. There's microwave Ethernet technology now, and we really are at a place where the ether can be anything, and it's an amazing time. We now have Carrier Ethernet 2.0, which has really taken Ethernet to the next level in terms of classes of service, delivering multiple classes of service, manageable, performance-assured services, and then the ability for service providers to have a standard way to interconnect with each other around the world. So, all this really drives the need for Ethernet in our business.
Thank you.
Sure.
James? Why doesn't James start off, please, by saying how he's been in that business 5 years and it's grown 15-fold?
Yeah, so I've been around longer than that, obviously, but in TATA I've been with the company for 5.5 years, and we've grown the Ethernet business by 15-fold, which is relatively simple when it's sort of single-digit millions, but it gets more interesting once you get to tens of millions, and now we're at hundreds of millions. So it's a very, very fast-growing industry. As Mark said, it's the reason why it's key to us is because it's key to our customers. And our customers are saying that Ethernet is the way that they want to do certain tasks. They don't want to do everything over Ethernet in the WAN, but they do want to do certain important tasks. And I think it's almost like the historical origins of Ethernet are coming back to support it once again. It started off in the LAN, and in fact it's the importance of the LAN today that is making it so important in the WAN. It's so important in the LAN because it's what connects together data center devices. So servers and all of those sorts of things are all, even if you're doing fancy things at a higher level, you're doing things with VXLAN or something at layer 3, you're still fundamentally plugging an RJ45 jack or whatever it might be into the back of a server. And that means that Ethernet starts all the way from the very starting point of the cloud all the way through. And if you can drive connectivity between those servers so that it stays within the same medium, within the same Ethernet frame, all the way through from end to end, then you have something that's really significant for the customer. And it comes back to a theme that's been quite frequently talked about this morning in particular, which is simplicity. The last thing that customers want to do is start layering multiple things on top of each other, and then they have competing interests from different protocols. Ethernet wants to behave in one way, IP wants to be routed in a different way, and trying to get those two things to line up. The fact that Ethernet can be used to extend data centers and make, we talked about virtualization in the previous session, virtualization of data centers starts to get very interesting. If you're virtualizing all your applications and all of your servers, then let's also talk about virtualizing your data centers so that Singapore and Hong Kong, at least from an application perspective, almost behaves the same way as if they're connected directly together on a LAN. That's quite transformational as far as a data center designer is concerned. And I suppose that the final aspect that we see is that because cloud has come on much faster than anybody expected it to do, it's grown much, much more quickly than anybody thought it would. Particularly as those of us that remember it, we had a go at it with application service providers, if you remember those. And in fact, I would argue that really cloud is a fancy version of mainframes, really, and shared access to mainframes. So we've seen this many times before, but now cloud has suddenly really taken off in a way enabled by internet and so on that's really exciting. As that happens and these environments become more and more large, Ethernet is absolutely there from the very beginning, and extending that across the WAN becomes something that customers really are interested to do.
Thank you, James. Yali, want to talk about Ethernet with Verizon?
Yeah, sure. So Verizon, as a global provider, that we definitely are there to provide whatever the services that our customer need. Ethernet is one of the fastest growing product we have seen in the last few years. And the customer require Ethernet, in our view, for, I believe, 3 reasons. One is that Ethernet provide the speed, higher speed, up to 10 gig in our case as a standard product. And number 2, it provides differentiated class of services. So it depends on the customer needs, then the customer could choose different service levels and pay different prices. And number 3 is that the customer is able to increase the demand for bandwidth dynamically. So with Ethernet, the customer could choose to up their speed from 3 meg to, say, to 10 meg or to up to a gig, and without have to change the physical interface. So with that, we have seen double-digit growth in the last few years in overall Ethernet services, growth in our product portfolio, and also from a global perspective, actually specifically outside of the US, we have seen very high adaptation of native Ethernet as access to our customers. Overall, we are able to provide over 80% of the solutions outside of the US, actually, from a local access perspective. as a Ethernet. And we work with hundreds of other service providers in addition to our own metro network to provide that to our customers.
Wonderful, wonderful. Does anyone out there have any questions for the panel here? Then I'll throw out another question to you folks. And if someone does have a question, raise their hand and we'll tag you. Oh, we got 2 questions. Okay. Mike, right behind you.
I'm Alan Weisberger with IEEE. I worked on the Ethernet first mile standard somewhere around 2000 to 2003. And it took maybe 6 years after that standard was completed, 2009, for carrier Ethernet, business Ethernet, metro Ethernet services to be deployed and then to ramp up. Why did it take so long? A lot of startup companies, including the one that I was in, didn't have deep pockets. We went belly up in the interim. Why did it take so long, and what's going on now that causes that market to ramp up?
I mean, we're in an interesting situation as TATA. Our home market, or one of our home markets, we have India and South Africa as home markets. Both of them have got historically relatively poor last mile infrastructure. And from our point of view, when we looked at things like Ethernet in the first mile, it requires a copper infrastructure. If you look at India, there are 40 million copper lines in India. That's it, and it's declining. So this is for a population of around about 1.1 billion people. So that's almost unusable as a technology as far as we're concerned in a home market. Now, change that to look at overall at a business. We're quite unique that we have a home market, but in fact 3/4 of our revenue is generated internationally. So we're all about long-haul intercontinental capacity, and we now with Ethernet services we reach 64 countries today with our own capability, and then we extend beyond that through NNIs. Every single market we go into has got different situations. Some of them have got legacy service providers who had copper infrastructure and they have implemented Ethernet in the first mile. It's an active market in France, for example. We can get good connectivity. UK, same sort of thing. But I've got an Ethernet node in Zambia. Let me tell you, there is no Ethernet in the first mile capability in Zambia. I have to buy fiber and all these sorts of things. So it really depends where you are, whether it got implemented or not, and really what the local infrastructure was that was there to support it. But for us as a service provider, as a competitive service provider, it's a huge enabler to bring large amounts of capacity to an end customer relatively inexpensively. Why did it take so long? We weren't there to push it, maybe.
Well, and maybe to add a bit to it, I think there's 2 dimensions. I think one is Ethernet as a service, as mentioned by James, and I think that's one dimension. The other dimension is Ethernet as a transport, right? And when you talk to service providers in those days, and we talked about, okay, we want to introduce Ethernet, then they said, that's great, we love it, but we want restoration, protection, traffic engineering, all the things that we're used to in the days of ATM, frame relay, SDH, SONET. We want to basically recreate it on Ethernet. And we had to actually come up with new technologies, new standards, and implement them, get them deployed, and that takes time. And I think that was one dimension of it. And at the same time, there was the access part and getting basically services off the ground and the local loops, et cetera. The service part is another dimension that service providers had to worry about.
Yali, I think you
Yeah,
wanted
I just want to add to that. Definitely the infrastructure plays a role here. So in the case of Verizon in the US, just this year we were able to launch 120,000 new lit buildings. That's through GPON because we have the fiber network in there. So when you have the legacy copper network, then you don't get the efficiency and the customer don't get all the benefits in the last number of years. So that's why probably the uptake was slower in the past, but it will go faster. And next year we plan to launch more. Yeah.
I'd just like to speak up as a vendor of some of those Ethernet and the first mile solutions. we saw the Ethernet over copper as, you know, a piece of the overall puzzle rather than sort of the end game. And what really bolstered the growth in carrier Ethernet was the evolution of the work out of the Metro Ethernet Forum, or MEF. And that's really because those services had to be defined and standardized. And we're really actually at a point now where things are taking off like crazy, and it's partially because there's now a standard interconnect among operators. And so at the external network-to-network interface that's been defined by the MEF, it's really enabled. And I think, Yali, you were talking over lunch that this is a huge enabler for Verizon as they move outside their traditional markets. So, you know, there's a big ecosystem component to this growth, and what has taken so long, I guess.
Yeah, definitely. Just to add to that, if I can, that in order for us to interconnect with the other carriers or use that as a last mile, then we have to certify each of those carriers. So the certification and the standards defined by MEF is very important for the carriers to work together and to go through the certifications.
Next question, please. Oh, we got two more. Yeah.
Yeah, hi. Okay, so what do you think is holding back Ethernet the most from all of you, please?
Well, I mean, holding it back in comparison to what, I suppose?
So what I would say is that people are still choosing TDM technology, SONET, DS1, DS3, even when Ethernet is available. And that means something is holding back people from buying Ethernet where they could. So what do you see is getting people to make the decisions to use legacy technologies even where Ethernet is available?
Human nature, I don't want to change.
Yeah, let me. So I asked our people what percentage of all the interfaces that we ship are Ethernet. 98 plus. So I think the reality of your question is suspect. It's almost entirely Ethernet. Where there is a legacy solution, some carriers running over SDH or SONET, they may continue to do that. But the new shipments are not just a small percentage Ethernet, and it's Ethernet in different forms. It's 10 gig, it's 1 gig, it's 100 gig, but it's Ethernet. It's that frame format. So, no, I think your question is incorrect. It's overwhelmingly Ethernet.
I think, just to add, I think if there's one thing where we've been held back and we're now moving forward, it's the wireless part, the mobile backhaul. I think when you look at standards like 2G and 3G, they were not really optimized around packets. And I think when LTE came around, it is completely IP optimized for packets, Ethernet. So, and I think a lot of operators are migrating. So if you look at, for instance, where a lot of these DS3s have been deployed, it's been to base stations around the world to basically maintain the service on 2G and 3G. And that right now, I think in the last few years has been accelerating. And if you look at, mobile backhaul solutions and vendors, it's a very, very interesting market right now.
Also, in my view, some countries, the pricing makes a difference as well. For example, in Canada, the Ethernet price for 2 meg or 4 meg is higher than, or 3 meg is higher than a T1 or 2 T1s. So the pricing plays a role here as well. And that's basically, I see that in North America, and amazingly, not so much outside of North America.
Good answer. Good. One more question here.
Do you see SDN like Nurgens? Or network with SDN, do you see them like that? Like a big evolution or a very important evolution for you? Or?
Is SDN an important evolution for carrier Ethernet?
Absolutely.
Well, I think that it's interesting because Ethernet is a protocol that's evolved without a control plane. So there are various ways to control and manage Ethernet and native Ethernet services, but usually it's inserted into something which in turn has a control plane like MPLS. SDN brings the possibility to have a native transport layer in Ethernet that is controlled by a higher order control plane. And I think that's an interesting innovation, and it's something that even as a carrier we haven't fully thought through what the implications of that are. But perhaps you could say that if an Ethernet frame originates from the back of a server and it can be transported all the way across the WAN as an Ethernet frame, and you could have a single unified control plane that took it all the way from the back of that server all the way across the world to another location, that's a very significant evolution, and we need to understand what the implications are of that. I think something else we see within SDN from a carrier point of view is, and again this is something that we're still thinking about what the impact of it is going to be, SDN has got the potential to flatten the network economics model. Before we used to build networks to meet a particular price point. So we might build a network or an offering or something to produce something that's very, very low cost, like for internet transport, for internet transit, for example. So we carry 4,500 petabits of traffic on internet every month over our network. In fact, using Juniper equipment. We could not afford to do that if we had many, many, many layers of complexity that sat within it. On the other hand, the services we provide on private MPLS or WAN Ethernet services have complexity in traffic engineering and latency concerns and class of service and prioritization and latency, strict latency controls, failover and all that sort of thing that needs to be controlled and managed, and that's very expensive. If you're saying 5 years from now, everything will have a common transport layer and there'll be a common control plane and routing layer, then that says everything costs the same. And as a carrier, we haven't thought through what the implications are of that. It costs exactly the same for me to carry an internet piece of traffic of somebody browsing YouTube as it does to carry a trade against the New York Stock Exchange. What implication does that have? We still need to think.
Thank you. So I'm going to say thank you, panelists. We've run out of time, and I would say press people, go nab them during the cocktail sessions, okay? And ask them questions because they would love to talk to you. Thank you.
Thank you, Tam. Thank you.